Okay, so in this video, we are going to verify the previous results that we computed in Google Colab. And namely, we calculated what happens when I take the product of BC and then multiply A by the result of that product. Is that change the result from what would happen if I first multiplied A times B and then took that product and multiplied it by C? And what we saw in Google Colab is that these two products gave us the same result. And we're going to check that a little bit more carefully here. So for question 1, first product we want to calculate is B times C. And so B is a 2 by 2 matrix. C is a 2 by 3 matrix. So this product is going to be defined. So when I take B times C, the definition of matrix product says we take matrix B times the first column vector of C. And this is going to give me the first column vector in the product. Then I take matrix B times the second column vector in C, and this is going to tell me the second column vector in the product. And then I take B times the third column vector, which is 2, 5, and this is going to tell me the third column vector in the product. So calculating this first product for the first column vector gives us 1, 6. I'll let you verify that when you take this product of B times column vector 2 of C, you get 15, 2, and B times column 3 of matrix C gives us 3, 10. So the result, this product BC, winds up being 1, 6 as the first column, 15, 2 as column 2, and 3, 10 as column 3. And notice we have 2 rows and 3 columns. So this is a 2 by 3 matrix. A is a 3 by 2 matrix, so we can multiply A times this product over here. So next I would take matrix A, which has first column 3 minus 1, 1, and its second column is 0, 2, 1. And I multiply that by the previous result that I got for BC, which is first row 1, 15, 3, and the second row 6, 2, 10. And I will save the details here, but you should definitely practice doing these by hand. And we do wind up getting the same result as we saw in Python. Namely, the top row is going to be 3, 45, 9. The second row is 11 minus 11, 17. And then the last row is 7, 17, 13. So that's what I get when we first calculated B, C, the product of B and C. Then I took A and multiplied it by that product of B, C. The calculations in 2 are going to follow a little bit differently, but we should wind up at the same solution at the bottom. Okay, so now we are first multiplying A times B. So A is a 3 by 2 matrix, B is a 2 by 2 matrix. This product is defined, so that's a good start. So to calculate the product of A times B, we would take matrix A, and we're going to multiply that by the first column of matrix B. And this is going to give me the first column in the product. Next, we would take matrix A again, and now we multiply it by the second column in matrix B, which is minus 1, 2. And this is going to give me the second column in the product. So taking A times column vector 1 of B gives us 12 minus 4, 4. Taking A times the second column vector of matrix B gives us minus 3, 5, 1. So therefore, the product of A and B has 2 columns. The first column is 12 minus 4, 4, and the second column is minus 3, 5, 1. So the product AB is a 3 by 2 matrix, and we're going to multiply this by matrix C, which is a 2 by 3 matrix. So this is going to work out. So now I'm taking AB times matrix C, which I've written out. And you can verify taking this product of AB times matrix C is going to wind up giving us a 3 by 3 matrix. First row is 3, 45, 9. The second row is 11 minus 11, 17. And the last row is 7, 17, 3. So whether I do B times C first, multiply A times that, or I do A times B first and then multiply by C, we get the same result in the end.